In the last lecture, we have discussed about the molecular mass. In this lecture, we will start talking about the formula mass. So, we have learned that atomic mass is the mass of an atom, molecular mass is the mass of a molecule. Now, what is the formula mass? The fact is, when we talk about molecules like water, carbon dioxide, methane, hydrogen, nitrogen, etc., for these type of compounds, single molecule of these compounds do exist. That is, one molecule of water, that is H2O, exists independently. So, we are able to calculate the molecular mass for it. But for some compounds, such as different salts, like let's say sodium chloride, the common salt. So, for sodium chloride, it does not exist independently in the form of NaCl molecule. In this case, sodium chloride exists in a form of large structures called crystals or lattices. So, in these crystals, a single unit of NaCl is not present independently. Rather, one ion of sodium is surrounded by 6 ions of chloride, that is Cl minus. So, one ion of Na plus is surrounded by 6 ions of Cl minus. Similarly, one ion of Cl minus is surrounded by 6 ions of Na plus. So, like this, they form large lattice structures. So, in case of salts like sodium chloride, potassium chloride, cesium chloride, zinc oxide, magnesium oxide, calcium fluoride, etc. These salts exist as lattices. So, in case of these salts, single molecules do not exist independently. Okay, single molecules do not exist independently. They exist in the form of large lattices. Okay, so lattices can have different types of structures. Okay, so large lattices. So lattices are large three-dimensional structures with different shape, sizes, geometries, and different physical and chemical properties. Okay, so lattices have different arrangement of atoms or ions, different shapes, different sizes, and their properties are also different. So, in these cases, single molecules do not exist independently. Okay, NaCl crystal or NaCl lattice is called 6:6 lattice. Why? Because 6 Na plus ions are surrounded by 6 Cl minus ions. 6 Cl minus ions are surrounded by 6 Na plus ions. Okay. So this is called 6:6 lattice. Similarly, cesium chloride lattice is 8:8. Okay. Here it's not exactly surrounded by how many ions. There are different calculations for finding these ratios too. So basically lattices have complex structures and single independent molecules do not exist there. So NaCl is not a molecule of sodium chloride. It is the formula unit of sodium chloride lattice. Okay. So this is called the formula mass, that is the mass of a formula unit. So formula mass is the mass of the formula unit which is commonly used to describe a lattice. Okay. So formula mass is the mass of the formula unit which is commonly used to describe a crystal lattice. Okay. So the formula for sodium chloride crystal is we can sodium chloride crystal also. Formula for sodium chloride crystal is NaCl. Calculation of formula mass is not very different from molecular mass. Okay. So calculation for formula mass is similar to molecular mass. Okay. Just the term is different. So formula mass of sodium chloride is equal to mass of sodium into number of sodium plus mass of chlorine into number of chlorine. This is equal to 23 mu, this is the mass of sodium, into 1, that is 1 is the number of sodium here, 35.5 mu, that is the mass of chlorine, into 1, this is the number of chlorine. So this comes as 58.5 mu. This is the formula mass of sodium chloride. So let's do some other examples. So the question is, determine the formula mass of the following compounds. Potassium sulfide K2S. Okay. So, okay, we will write the questions first. BaClO2. KMnO4, NaHSO4, PbSO4. Okay. So the formula mass of K2S is again mass of potassium into number of potassium plus mass of sulfur into number of sulfur, which is 39 into 2 plus 32 into 1. This comes as 78 plus 32, which is equal to 110 AMU. Okay. B, BaClO3 whole 2. So mass of barium into number of barium plus, now this is whole 2, right? So 2 into mass of chlorine into number of chlorine plus mass of oxygen into number of oxygen. So this is 137.3 into 1 plus 2 into 35.5 into 1 plus 16 into 3. So 137.3 plus 2 into 35.5 plus 48. So this comes as 304.3 AMU. Okay. Now number 6, potassium permanganate. This is equal to mass of potassium into number of potassium plus mass of manganese into number of manganese plus mass of oxygen into number of oxygen. So this comes as 39 into 1 plus 54.9 into 1 plus 16 into 4. So this is 39 plus 54.9 plus 64. So this comes as 157.9 AMU, which can be considered as 158 AMU. Okay. So the next one is sodium bisulfate or sodium hydrogen sulfate, NaHSO4. So mass of sodium into number of sodium plus mass of hydrogen into number of hydrogen plus mass of sulfur into number of sulfur plus mass of oxygen into number of oxygen. So this comes as 23 into 1 plus 1 into 1 plus 32 into 1 plus 16 into 4. So this comes as 23 plus 1 plus 32 plus 64. This comes as 120 AMU. Okay. The last one is lead sulfate, PbSO4. So this is equal to again mass of lead into number of lead plus mass of sulfur into number of sulfur plus mass of oxygen into number of oxygen. So mass of lead is 207.2 into number of lead is 1 plus 32 into 1 plus 16 into 4. So, this comes as 207.2 plus 32 plus 64. So, this is 303.2 AMU. So, we have learnt to calculate molecular mass, atomic mass and formula mass. Now, we will discuss a very important topic, that is the mole concept. Okay. So, mole is the SI unit for amount of substance. When we were studying about the 7 basic SI units, we had also studied about mole. So, mole was later on introduced as the SI unit of amount of substance. Now, there is a definition for mole and there are certain formulas for calculating the mole. We will learn that now. Okay. So, let's start with mole concept. Okay. So, the fact is that atoms and molecules are very small in size. So, their number of atoms or molecules present in even a small amount of substance is very large. Okay. So, to handle such large numbers, a unit similar to that magnitude is required. So, in SI system, mole is one of the 7 base units. It is the unit to measure amount of substance. Okay. So, what is the definition of 1 mole? So, definition of 1 mole. So, 1 mole is the amount of a substance that contains as many particles or entities as there are atoms in exactly 12 grams of carbon 12. Okay. So, 1 mole is defined as the amount of a substance that contains as many particles or entities as there are atoms in exactly 12 grams of carbon 12. So, the number of atoms in 12 grams of carbon 12 is, they have a certain number. So, when some amount of substance contains that exact number of particles, that is called 1 mole. Now, these particles can be atoms, molecules, ions, subatomic particles like electron, protons, etc. Okay. All of them can be counted as particles. So, mole is a physical quantity that is dimensionless, and 1 mole represents 6.022 into 10 to the power 23 particles. Okay. So, this is a very interesting number, 6.022 into 10 to the power 23 particles. These many atoms of carbon 12 are present in exactly 12 grams of carbon-12. This number is called Avogadro's number. Okay. So this is called Avogadro's number, and this is the definition of 1 mole. We will study in details about various aspects of mole concept and why Avogadro's number is so important in the next lecture. Thank you.